Okay, folks, let's talk about, see this function f of x is equal to 2x plus 5. How would I do f of 1? Well, see, the 2x minus 5, it's the process. And what we're doing is we're putting values into the function, in for the value of x. So that would be 2 times 1 plus 5, or 2 plus 5, which is 7. So we say f of 1 equals 7. How about another number? How about f of negative 3? Same thing. 2 times blah, that's our input value, negative 3 plus 5, negative 6 plus 5, that's negative 1. So f of negative 3 is equal to negative 1. Now, what do we do when we have letters? Okay, so I want to know what f of big A is. Well, the function process is 2 times blah plus 5. And we put our input value for blah, so really f of A is just 2a plus 5. If we could understand it with the numbers, we could understand it with the expressions. Now, one quick thing here. F of x plus 1. Now, what would I do there? Well, let's take the same general idea, 2 times blah plus 5. What are we going to put? What are we going to put in here for our input value? So I don't want you to confuse this x with this x up here. This is what we're putting in. I've defined f, the function, as this. So this is my definition I'm working on. This is what is under consideration. So whatever I see my x, I put in x plus 1. This is 2x plus 2 plus 5, or just 2x plus 7. That's what's going on with that. So keep that in mind. Now, one last question about this. Someone could say, okay, well, what if I give you an output value? What if I tell you that f of x is 25? Can you find x? F of x is 25, so 25 is equal to 2x plus 5. Now, lo and behold, we have a linear equation. We've been through this before. Subtract 5 from both sides. And what would we do here? We would have to divide by 2. So x is what? X is 10. So before it was, you give me a number, I'll give you the value of the function. Here, I gave you the value of the function, and you had to give me the input value. Let's see, what else do I want to say real quick? We're talking about some basic ideas here. So here is a function. Now I'm going to call the orange curve f. That represents all of the values that are represented on the graph, and those values form the orange curve. So the orange curve is just, all it is just a series of points, just like I did the circle. Okay, so now my question is, can you tell me what f of 0 is? F of 0. Well, my 0 for my x is right here. Okay, so if I go up to find the orange function, I can find the y value there. What is the y value there? The y value there is 1. So isn't 0, comma 1 a coordinate, a point, the coordinate of the point that is located here on the curve? So I hope that makes sense. Now, the last thing I'd like to share about this is when we're looking at curves, we've got to be able to identify the domain and the range. So the domain are the x values that are used. You may be able to see this quickly and say, well, the curve goes to the left right here at -1, and it's included, and it keeps on going to the right forever, so infinity. That would be the domain. let's talk about the range. Well, that's up and down. How far down does the curve go? It goes down to this point right here. What's the y value there? The y value there is 0. Now, how far does the curve go up? I don't care right or left. I just care about up. And so if the arrow indicates any direction up, which is just a slight up, it's going to go up. So that would be 0 to infinity. Now, someone may say, I really don't see that. So the way to do this is, what is that ordered pair right there? It's -1 comma 0. Okay? Remember, domain are the x, the range is the y. Is that -1 included? Yes. So domain -1. Now, does a curve go to the right forever? It does. So there you go. It means infinity. Let's try the range. The range or the y. What's the starting point? 0. It doesn't go down any further. There's no orange below that point. And it goes up. So 0 to infinity. All right, I do hope that helps you out a little bit about functions that may help you. All right, good luck.